Good afternoon, everybody. Boy, I didn't realize what kind of a walk it was from the one end of the place to here, so I really appreciate you guys taking this effort, because I knew it was a long convention center, and I had left a half an hour, and boy, I barely got here in time. So hopefully what I'll be covering is going to be worth your time here. So my name is Manfred Arndt. I'm from HP Networking's Advanced Technology Group, and that's our CTO office looking at next generation technology. And my role is on unified communications and mobility, and I've been driving that since 2003, and I've been working very closely with Microsoft Lync, technically on a strategic level. So we're going to cover a couple key topics, kind of some of the key design considerations for enterprise voice. It's, there's some significant challenges to make sure you do this right when you're replacing your PBX. Provide some best practices to make sure you have successful migrations. And then a little bit of overview of some of the solutions the HP network provides for Lync. Before I start, I'd like to tell you a little story. I was doing a similar presentation at Enterprise Connect on QoS design best practices. And at the end of the session, a guy came up to me and he goes, "Wow, I wish I had known this stuff beforehand." He was with a fairly large company, close to 100,000 people in EMEA, and they'd done a Lync pilot, and everything was going really good. No problems or anything like that. And they started rolling out to larger deployments. And as the usage started going up, they started having all kinds of audio quality issues. And he started getting some flack for that. And then he realized that the networking guy was a Cisco bigot, and he ensured that Lync did not get QoS. And at that point, the networking guy, who was also the Cisco voice guy, said to his boss, "See, I told you Lync wasn't ready for prime time. My work was good on a small scale, but not on a large scale." So, the lesson there is, proper designs up front, during and before the pilot's critical, because don't let that happen to your deployment. And, once that happens, it's a lot harder to correct that problem. So we're really, right now, in a, fundamental transition of communication applications. We're shifting from what used to be a PBX platform into a cloud platform, kind of, hybrid kind of cloud platform. And there's a couple, three key things that are driving it. We're much more application-centric. We've got, really smart mobile devices now. And we've got, rich networking capabilities. But the challenge is many of these enterprises have deployed, they still have 15 to 20-year-old PBXs deployed. Even if they've deployed VoIP, a large number of enterprises out there and customers are still running, especially in some of the branch environments, not 100% VoIP across their organization. So they're still running 15, 20-year-old PBXs. So trying to move that into the cloud is a little challenging. So UC's often not quite cloud ready yet. So getting to a solution like Lync, which is really about application-driven, is a good first step, and really the right step you need to take to drive, the next wave, which will be coming. Now, something that people may not realize is, as applications move into the cloud, and often Lync is being driven by the application guy. So the application guy came from the, Office world, SharePoint world, and they see, how Lync is great for IM presence, and they start using that for voice capabilities. Other applications, the network is just a fat, dumb pipe. So it doesn't really matter if there's some issues with the network. But, most client-server applications are really all the data traffic is going into the cloud and back, or into the data center and back. There's a lot of significant difference with voice and real-time communication. One, it's very jitter and latency sensitive. It's very sensitive to packet loss. You can't retransmit the voice packets. And the traffic is mostly peer-to-peer. Once you've established the signaling, the traffic flows in a completely different pattern than your typical client-server application. So the network design, things like QoS, bandwidth management are very, very important. The experience will suffer dramatically. Most data applications, if you start congesting the network, will back off nicely. Their email, their PowerPoint downloads, their SharePoint downloads will simply slow down a little bit. Users won't notice. Real-time communication, however, if your network can handle, say, 10 calls, once you hit 11 calls, the call quality starts to suffer dramatically. And once you hit, say, 12 or 13 calls, it's not the last 2 calls that suffer, it's all the calls suffer. So it degrades all the calls. So that's an important part, the distinction that people have to remember when you're doing these, and why in a pilot things might go well, but once you start going to a large-scale deployment, you may start seeing issues. So HP's been involved with quite a number of link deployments, UC deployments, and want to share some lessons we have from the field. Plus, I'll also share what we've learned internally, because we're right now probably the largest link deployment, both for IMINT presence and voice, and I'm going to cover that near the end of the presentation as some of the lessons we've learned from the field. What I don't want to have happen is, if the pilot worked great, why do deployment stalls? And we've seen that on a number of cases. So what are some common pitfalls when people are, deploying Link Enterprise Voice? Big one is insufficient planning, and the other one is poor communication. So something people need to remember is we're really going through an organizational shift here. Maybe 10, 15 years ago, the voice group was running the voice, the PBX. And then with VoIP, it was the networking group that was running that. But now it really is an application-driven deployment, and that's where it belongs. It's not a networking-driven deployment, it's an application-driven deployment, but the networking is an important aspect of it. So you need to work across more groups. So whether you're doing an internal deployment or you're a partner and working with a customer, make sure you get the right stakeholders involved early on in the discussion, prior to the rollout, prior to the pilot, to set the right expectations, to set the right requirements on what you need to do. Network assessment, on the order of 75% of deployments require some kind of network upgrade. It might not be extensive, but some type of network upgrade or WAN upgrade is required to ensure that you have the right experience. You need to do the right capacity planning. What is the right number of calls you want to do? And some of that is looking at existing call logs. But interesting lessons we've learned is the call usage patterns will change. People will start using, because of how easy Link is to use, they'll start using the application more, and I'll share some of that a little bit later on. You really have to look at, how much you're going to leverage your PSTN or how much WAN capacity you need to increase, because that's an important aspect that sometimes people don't adequately look at. And it's also as important, are you just a USA deployment or are you a global deployment? And WAN costs in the USA and EMEA are quite reasonable, but in some places like Africa, the WAN costs are very expensive, and the cost of migrating the PSTN traffic to the WAN may not make sense. But within the USA, for example, if you have a larger site with, say, 4 T1s coming in, reducing those T1s, you probably don't want to eliminate them because you want some survivability, but reducing the T1s and running more of that through your data center is probably pretty cost effective, because with a PSTN, you're typically not running at full capacity. And say a PSTN costs you $400 for a T1, full T1, that price isn't going to go down. If anything, it's going to go up because the number of people on the PSTN is decreasing constantly. So if you can take that traffic and take that money that you spend on the PSTN and apply it towards a WAN, you can use it for voice, video, data, and other applications. And the WAN cost constantly keeps coming down. For that same $400, often instead of getting 1.5 meg, you're getting 10 meg or sometimes even 100 meg. So you get significantly more capacity by reducing your PSTN, but you got to be careful, and you have to look at how important is survivability for the different sites. Make sure you don't overlook simple things. It could be as simple as edge services. It could be accidentally running traffic through your a VPN. Those things can cause audio quality issues, and at the end, people will blame the network or they'll blame the application. But there's a lot of things, even poor headset choices, even poor endpoint devices. So make sure you don't overlook the simple things. Like you reiterated before, proper communication is really important to make sure you keep the right stakeholders in your organization informed, and you do periodic updates on what you're going to be rolling out. So from a network assessment, it's really important to understand what is the existing usage model. And from that, you need to look at how many sites do I have, and like I said, look at the existing capacity that your existing PBX had or IP PBX had, and that's a good starting point. However, something we've learned through some of our deployments is people's usage of voice had really been going down. They'd been starting to use more texting or IM. Link, the client is so good with doing an IM session. But we've seen that customers who started doing large enterprise voice deployment, their voice usage actually goes up. And at first it was like, why is that happening? But I myself have seen that as well. Because in the past, you're getting email, you're getting voicemail. It's hard to get a hold of a person. But with an IM, you can start a chat session, and pretty quickly after 3 or 4 IMs back and forth, you start realizing, hey, let's just make a call. It's so convenient. You just click on it. Next thing you know, you can do desktop sharing. So it's a way to encourage users to embrace it, rather you, from an IT standpoint, forcing users to use it. And so what we've seen works really well is do it as an overlay and continue running the PBX for appropriate length of time so your user base feels comfortable with migrating it over to the solution as opposed to forcing it. If you force the users over, they'll be upset, they'll be frustrated, they'll blame IT. But if you keep it as an overlay for the appropriate length of time, they'll actually embrace it and they'll tell their peers about how great it is. We've seen that internally as well. And the cost savings is tremendous by doing that, by letting them embrace it as opposed to forcing it down them. Make sure you do an infrastructure assessment. Make sure you inventory, how many legacy PBXs you have, how many desk phones you have. People often don't realize the desk phone at times is about 40% of your voice deployment. So when somebody did a IP-PBX deployment, 40% of the cost was on desk phones. And if you've got IP-PBXs that are, say, less than 2 or 3 years old, those are probably not the right sites to target first. Target the sites with the older PBXs. That's where you can get some dramatic cost savings by upgrading those first. And then amortize the sites later that are still running VoIP. If you've got some newer solutions in there, Link works great in a hybrid deployment model for larger customer deployments. If you're a smaller customer, let's say you're in the 1,000 user range, doing a complete cutover is feasible. But if you're larger, we just don't see that being practical rolling that over. So you're going to have much more success as an organization if you approach it in a pragmatic manner that shows how to save costs first. So target the highest ROI initiatives first. Like, conference calling is a great example of how to reduce that. Reducing some of your PSTN minutes is a great way of reducing that. Reducing some of your travel costs is a great way of reducing that. And by doing that on a few sites first, you can really get support from your CIO that they see how effective their cost savings are, and then they'll embrace you to drive more of that across more of the sites. And don't try to do too much at once. So what we've seen is, it's really good to do some smaller steps first. Don't, for example, try to do mobile clients with voice enabled at the same time you're trying to do the desk phone upgrades. Pick some good targets, do those first, and then add on to it. And we've seen that being very, very effective by doing that. Because there's a lot more, Link is a lot more powerful, has a lot more capabilities, but it's also a little bit more complex because of the flexibility and the capability it provides. And the last one, we've seen it really, really working well. Because, when we are in discussions with customers, most customers understand the value UC. They go, I get it. We want to deploy UC. But the biggest problem they often run is we simply don't have the budget to fund it. And if you look at some of the competitive solutions out there, the cost to migrate can be pretty high. And in many cases, like I said, you need to do a network infrastructure upgrade as well. So once they start doing the planning, the scoping, they look at the cost, the project stalls because where you can get that pool of money from. Okay? That is invariably a big problem. And we've been very effective at going in and showing customers, first focusing, what are you trying to achieve? Because different organizations have different needs. Some organizations are more sales-focused. Some organizations are more support-focused. Some organizations are more mobile. Find out where the biggest cost savings for your organization is. Target those areas first, and then you can get some tremendous cost savings. And once you use those cost savings, then you can fund the additional upgrades. And we've got some studies in here. Big aspect is many customers are still running Cisco networking out there. With HP Network, they get a much more flexible infrastructure, and they can support multi-vendor environments very well. And we have optimized solutions for Link, and we have got a complete portfolio. I'll cover that next. And we've shown case studies where we show customers a 47% ROI over 3 years, and that combined with the link cost savings is pretty tremendous. Question over there?
Yeah, so when you are trying to put together a statement of work or proposal for mid-sized companies, the first thing they try to cut out of that statement of work is that network assessment. So what are some of your ideas to kind of hold the line on that, and what's the typical length of time that you take to do an assessment?
That's an excellent point because they feel that somehow it isn't necessary. And maybe a complete network assessment is not where you need to start right away because they might view that as overly expensive, but you need to start on a few target sites that they're going first. And so that should bring the cost down, and at that point when you do that network assessment on there, they'll start seeing, what shape is our infrastructure in. The targeted length of time, that can vary. But I think what's worth highlighting is, look at some of the case studies we've done that shows by doing the network upgrade, they actually get cost savings in addition to a more reliable and robust infrastructure. Because the last thing you want to do is not do that network upgrade and run into all kinds of problems. Because when customers are taking a PBX, that's been 5 nines reliability, that expectation is still there, maybe not quite the same reliability, but they expect a pretty highly reliable solution. They're getting a lot more bang for the buck. They're getting a lot more capabilities. You're not comparing apples with oranges. But if you can't reach a good level of reliability, they're going to be frustrated and upset with the deployment, and you're going to have a black eye. So, do highlight them how critical the network is from an availability standpoint, from a reliability standpoint, from an interoperability standpoint, that network assessment is really the lifeline of that, link deployment. Did I cover that? Endpoints matter a lot, too, from the quality of the experience. What we've noticed is as organizations are more geographic in nature, we tend to, and when you start deploying solutions like Link, you tend to do a little bit less travel. Sometimes a lot less travel, but we're on the phone a lot more. And the experience of doing conference calling, the scheduled meeting where you just click on a scheduled meeting, when you are invited, you don't have to dial in all the conference digits to get in there. It's so much easier to do the conference calling. We see the use of conference calling is going up, but all it takes is one user on a mobile phone, cell phone, with a poor audio quality to ruin the experience for everybody. And that's much more noticeable now with RT audio. When you're running an RT audio session, the audio quality is a high fidelity, much higher than the PSTN. We actually have, our CIO did a rollout and was running Link, and he called his wife on his Link phone, and his wife was in shock. She goes, "What did you call me on?" He goes, "Why? Just a Link phone." He goes, "Well, no, whatever you called me on, I don't want to know about the technology. I could really hear what you're saying. It was crystal clear. Never call me on that other phone again." And that experience we see is, especially when you're talking to people, in other countries where their English may not be as good or the accent is a little harder. Sometimes I had a really hard time on a regular PSTN call through a regular conference service to hear what's going on, especially as more and more people are running mobile devices or they're running more VoIP, because we're doing a lot of transcoding along the path, and the audio quality is really suffering. That's why I find the higher fidelity quality on, say, HD audio or RT audio makes a big difference. But at the same time, if they don't have good headsets, or if they have laptops that are not optimized for Link, all it takes is one user shouting in their laptop to ruin the whole experience. So do make sure you provide your users or recommend the users on an appropriate set of endpoints. And what we've seen is, it used to be that IT provided all the phones. Right? As part of a PBX deployment, they provided all the phones and all the endpoints. But that's changing. In many organizations now, the cost of the endpoints have come down so low, they're really an expense item. And what we've also seen is user preferences matter and are relevant. So we found it's best to actually give a list based on the user's roles. Let's say they're a knowledge worker, a mobile worker, an executive, an admin. You give them a list of approved devices, just like you give them a list of approved laptops. You typically give your end users 1 or 2 or 3 laptops to choose from. You should be doing the same thing from a Link deployment. Let them choose the headset. Some people hate headsets because it messes up their hair. They don't want to have a bad hair day. Some people like, 2-ear headsets. Other people still love the phone. Okay? Sometimes multiple devices are practical. Just like people have a large screen monitor in their laptop in the docking station. It makes sense for people who use the phone a lot or on the phone a lot to have both a desk phone and a headset. The productivity gain is much higher than the cost of the headset. So when people say, there's no more phones needed, that's not true. What we see is the vast majority of Link deployments we've done, there's still phones out there. It's just not that there's not a 1-to-1 or more than 1-to-1 ratio of phones to workers. If you had an organization with 1,000 workers, you typically had, say, 1,200 phones because you had conference rooms, you had lobby phones, and every user had a phone. That's not needed. You may need in the order of, say, 20 to 40% phones for the user population based on who the users are. Some users don't use the phone much, but for other ones that need the phone, having a reliable phone that's always on in the right form factor will provide a better experience. But it's often best to let the end users dictate that. Now, for admins and executives, absolutely recommended always to provide a desk phone for them. Set proper expectations. So communicating the strategy and the roadmap is really good to encourage user adoption. Make sure you have the right procurement processes in place, and do that as part of the pilot. So when you're doing the pilot, do that how the users would actually order the real devices, how they would go through the real support process. Don't circumvent that for the pilot. As you're doing the production pilot, you want to learn how to do that for the full-blown deployment. And setting that right expectation during that pilot may seem silly, but when we've done that with customers, they've seen that working really well. Make sure you provide sufficient training. Link is pretty easy to use, but it's good to also provide sufficient training. It could be online training, okay? But just provide them as part of the communication, some easy guidance on what the different tools are so that they want to encourage the use. Make sure you maintain your user experience. The last thing you want to do is have people have a bad experience for the first couple times they try something. Human nature is you try something only once or twice, and if you have a bad experience, you're not going to go back to that. Okay? So if you roll out too much initially, and your network isn't ready or your infrastructure isn't ready, and you start deploying that, if your customers start using it and you start trying to do desktop sharing and the desktop sharing experience sucks, they're not going to try it again, and they're just going to badmouth Link. Oh, it's a piece of crap. Every time I bring it up, it fails or it doesn't refresh properly. So, make sure as you're doing the pilots, you're monitoring the user experience. And just because users don't complain doesn't mean there isn't a problem. Okay, I've heard many IT departments, including our IT department, say, oh, no one ever complains. No, only really frustrated users complain. Most users, if the phone's not working properly, guess what? They'll grab their cell phone and just bitch. Okay, so, in Microsoft Link, you've got the archiving server role where you can look at QoE stats. Make sure to turn that on and monitor that regularly because you'll get to see the real call quality experience that the users are getting and track that over time. Make a baseline and periodically check that as your adoption grows. Are they having the right call experience? And the beauty is with RT audio, it suppresses a lot of the packet loss. It has a really good job on packet loss concealment and does a good job on a network where there isn't appropriate QoS. But the call logs in there will show you what type of impairments it corrected, so you actually know if you've got a poorly operating network, even though the users may not be experiencing the problem yet. And make sure to do that periodically, both through the pilot, the migrations, and even post-rollout, because once users start using this, like I said, their usage models actually starts to change. And once you've deployed it, say, for wired phones, you'll probably start rolling out mobility solutions as well, and new challenges will arise with that. So what I want to do is cover some network design considerations to support multimedia. And the reasons is, voice and video places significant demands on the network. Voice itself, from bandwidth standpoint, isn't that much. It's really about, the end-to-end latency and the jitter and packet loss. So voice hates packet loss. So if you're seeing packet loss, the packet loss concealment algorithms can only do so much. Some intermittent packet loss, periodic, not a big deal, but bursty packet loss will impact audio quality. Video, on the other hand, one video call can easily equate 20 times the bandwidth on one voice call. And if you enable both voice and video on the network, and you're not, don't have the policies appropriately set, the video can quickly overwhelm the network, especially as adoption grows on that. So there's a number of network design considerations. I'm going to only touch briefly on some of them, and I'll drill deeper into the QoS aspect of it. There's a couple areas you really want to look at from the network design. One is topology. Understand your network topology and how the traffic flows. Your traffic flows will be different because what may have been going on at the PSTN locally will now run over your core backbone. Depending on where you placed your data centers and where if you start looking at SIP trunking, that can change your traffic flow. So understand that. Bandwidth. So that one's an important one. You will need to make sure you have the appropriate level of bandwidth for all the branch sites, especially ones where there are not a lot of PSTN locally. QoS. QoS, you don't have to get fancy with QoS. So a lot of times people try to get really fancy with QoS. Fancy is not what helps you. What you want to do is have a consistent QoS policy end-to-end. That's the important part. QoS is only as good as the weakest link. So if you've got one or two bad areas, that can cause a lot of problems across potentially all your user bases. So it's more about making sure you get a consistent and appropriate policies than getting fancy with it. And we recommend doing both an L2, Layer 2, and Layer 3 QoS policy. But the Layer 3 is really important. I'll touch on that a little bit more in a subsequent slide. Resiliency, so high availability. As you're running more of your traffic now over the network, that's key. So things like a UPS backup to provide power to switches is something you should think about, especially for critical sites. PSTN survivability, so like the survivable branch appliances, those are an important aspect for critical sites. HP's got some. I'll cover that a little bit later. But also things from the network infrastructure so that if a switch fails or something, you have a hitless failover. We've got a technology called Intelligent Resilient Framework, which is a technology that allows you to take multiple switches, turn them into one larger switch, and if one switch needs to be brought down, say you're doing a software upgrade, or for whatever reason the switch, the software in the switch has a problem, the network will seamlessly continue running, and you will have zero packet losses, and you will not have any noticeable impact on the applications running. PoE and PoE Plus. Desk phones aren't going anyway soon. And so as people are migrating, so this is an important aspect. If you're doing a UC deployment, it's often a very good time to do a refresh of the Layer 2 infrastructure to support PoE and PoE Plus. And in many cases, doing that upgrade can actually save you money. And the PoE is useful not just for IP phones, but when you're doing wireless deployments, you need it for access points. And VDI thin clients, there's now a number of thin clients that run fully on PoE, so you only have one cable to plug in. So it makes deployments much, much easier. And the cost difference between PoE and PoE Plus is minimal. So even if you might not need the PoE Plus today, the recommendation is deploy the PoE Plus, because what we're seeing these days, people are not upgrading their switches every 2 to 3 years anymore. Average expectancy is more on the 5 to 7 year time frame. And so you have to ask the customer, what type of applications, what type of bandwidth do you think you're going to be running your network in, say, 5 to 7 years? And once they look at it from that standpoint, the PoE Plus upgrade is pretty common. Security, make sure I don't recommend doing all the security up front because it's more important to get the pilot up and running and working, and security tends to break things. But as you're doing the pilot, make sure you've got the right security capabilities in the network switches. For example, network access control, 802.1x, and those kind of things. I wasn't talking about security from the SIP TLS or from a link standpoint. Of course, you want that enabled by default. But I was talking about some of the network security capabilities. There's a lot of capabilities that are built into the network infrastructure that can help you protect the network, and with software-defined networking, which is a topic I'm going to touch briefly, things like security will become much easier. So make sure your network infrastructure has security, because security is really about layers of security to help build a better protection. And then monitoring. Clearly, monitoring is very important so that you can continue seeing what's going on in your network. Covered most of this already, so understand the concurrency models, understand whether you want to use the PSTN versus more WAN bandwidth. In most cases, the WAN is much more cost-effective than the PSTN, so if you can reduce some of your PSTN trunks, don't eliminate them initially because you want to have a survivability solution. That can help you fund your UC or link deployment, by reducing the number of PSTNs you have. And you're going to get a much better utilization in a centralized architecture. Even if you're not doing SIP trunking, even if you're just running the PSTN trunks to your data center, running the VoIP from your branch to your headquarters and doing the PSTN in the data center, you're going to get a better utilization because on average, any given site may be only 25% utilized. So you can get a better utilization by reducing that a little bit in the branches and centralizing that. And then with the wireless, until you've got really good experience with voice deployment at a fairly large deployment within the enterprise over wired, my recommendation is be cautious on wireless because there's a lot of additional challenges, including making sure you got the right 802.11n infrastructure. The AP placements needs to be a lot closer. You need to make sure you have new enough devices that support the appropriate standards. So, make sure you really have a good understanding with how to troubleshoot the link problems before necessarily going into a voice over WLAN deployment. It can be done, but it does take, site survey is a critical aspect of doing a wireless voice deployment. Modeling the network traffic. So why is modeling the traffic is important? You need to understand the user modalities. Different users have different modes. And so what you want to do is, really understand what type of knowledge workers have, what type of mobility workers do I have. Yes?
Just on the previous slide. That it's on. There we go. Just on the previous slide, I had a quick question about branch, the actual network between branching. Is there any study or any information or guidance on the different types? Does it make a difference? I've got an EVPL line between two locations versus MPLS. Is that a voice over IP concern, the way the routing, the QoS work, and so forth?
Repeat the last part again about the TLS or?
Sure. So Ethernet virtual private circuit between two locations.
In MPLS.
I'm sorry?
You said in MPLS.
Versus MPLS.
Yes. Yeah, so I mean, wherever you can within the enterprise, you're going to want to run over the WAN. When you can, you're going to want to run an MPLS circuit wherever possible. Because my analogy really is kind of a freeway. We've got four-wheel drive vehicles that work great on rough roads, but you're going to get a much better experience driving them on the freeway wherever you can. So wherever it's practical and cost-effective, you want to run it over an MPLS network with QoS services on there. The vast majority of voice deployments are like that. Now, for a smaller remote site where there aren't as many users running it over a DSL or VPLS kind of circuit, it's adequate, but you may experience intermittent problems, so you won't be able to provide the same level of reliability. There is no QoS over an open internet or some of these virtual networks. So, you do need to set that right expectation to those users. And in those sites, you may want to consider continuing having a PSTN there for either survivability or in case they've experienced a poor experience over the open internet. So, modeling is important so that you have a right expectation of what the user's experience will be and how much desktop sharing they might be doing, how much video they might be doing, and appropriately plan, the WAN bandwidth increase that might drive. And like I said, the future real-time traffic profiles can be very much different than today's traffic profiles once Link is deployed at full scale. We've seen that in many, many customer deployments. So, a lot of times people are going, well, people aren't using the phone that much. They will use it more once they deploy Link. And like video, for example, is really a generational thing. I find people my age rarely even want to use video. We're embarrassed. We go run to the bathroom first. We make sure we do our hair. We look at our surroundings. And when we put it on, we feel uncomfortable. Well, the younger generation that's coming into the workforce, they're used to using Instagram. They're used to using, Snapchat and all these, Skype and all these applications. And they don't even worry what they look like. I mean, they embrace that. Just like you and I, when we're out here, we don't care what we look like. This is, to us, the real world. For them, UC and collaboration is just like the real world. So they will embrace, they will demand those type of solutions. So what I want to highlight from the networking challenges around QoS, there's really two key areas in the network where QoS is a problem. And I want to explain kind of why that is starting to become a problem, much more so than it has in the past. me see if there's a pointer in here. Yeah, there's the user access layer and then the enterprise edge, kind of like you were highlighting towards the service provider. These are the two big areas where you're going to have problems. And in the world of the IP PBX, so if you're running, say, a VIA or Cisco Call Manager, QoS was very simple. So for the last 10 years, deploying QoS has almost been a plug-and-play kind of thing. The phones set the right layer 2. They set the right layer 3 QoS. And you run on a dedicated VLAN. Virtually every voice deployment we've done is on a dedicated VLAN. In many cases, the phones are on a private IP address, like a 192 address, so they can't even communicate to the rest of the network. So setting the QoS on that VLAN is trivial. But what's changing is we're now running it on laptops. We're running voice, video, and data on that laptop. And worse is we're bringing in BYOD devices. We're bringing in, devices that are consumer devices. And with Windows and many endpoint devices with laptops, QoS is not enabled on that endpoint. And even if it was enabled, it can be tricky and hard to enable on all the endpoints. But many organizations we find simply don't want to trust the endpoint, especially as the organization size goes up. In a smaller organization of, say, 100 or 200 people, probably not an issue. But if you've got a 10,000 user organization, you don't want to trust the end user because, BitTorrent or World of Warcraft runs a lot better when you put it at expedited forwarding and you give it high priority. It runs really well, but your link deployment starts to suffer. So some of the things you have to really look at is how do you provide application awareness? How do you mark the QoS at the ingress? So a key concept really is you want to mark the appropriate traffic at the ingress, because by doing that, it keeps your core network policies very simple. Doing the core policies now, you keep very basic policies that says voice is a certain priority, video is a certain priority. It's static throughout your network. And by doing this now, the only place you really have to worry about is at the access layer, identifying the right application type and marking that. And then from the rest of the network, you're simply honoring that throughout the network. The other place where there's a lot of issues is right around the WAN right here at the enterprise edge. Because you might have multiple service providers, few companies that span multiple states can have the same service provider. You may or likely will have different MPLS QoS policies. You might have 5 QoS priorities from one provider. You might have 7 from another. And there tends to not be a single standard for the DSCP code point markings. So while it's recommended to have a consistent policy within your organization, you may need to do some simple remapping at the WAN router to remap what a video policy is to say the service provider's equivalent of that video policy. The other issue is things like policy-based routing, because you may have both an MPLS network, but you may have DSL or some other network that's lower cost, run the data traffic, web traffic, over the DSL. That provides you cost savings, and that frees up the MPLS for more mission critical or traffic that needs higher priority of service. And then, leverage the PSTN or SIP trunks where it makes sense. Admission control is an important concept, but it also becomes very hard and challenging. So the point being is for IP phones, you want to trust those. With link phones, that's very simple. They run LLDP MED. You plug them into the network automatically advertises what the voice VLAN is. The phone discovers that, boots right up, and you're good to go. And that makes that policy very simple. You can trust the endpoint. With the laptop, employee-owned company-owned laptops, you're going to want to conditionally trust only the voice and video, and you're going to want to remark the other applications down to priority 0. And then guest users, you're not going to want to trust those, but as you start migrating in the future solutions to mobile devices where some are employee-owned, you'll have to figure out how to properly prioritize that traffic too. So what I kind of touched on with QoS, there's a couple things that are really key to achieving proper QoS. One is classifying traffic. So the first step is, how do I identify what one traffic is and treat that differently from the rest? The next is, once you've identified that traffic type, how do I queue it and schedule it in the different priority queues? Then the marking aspect, which is starting to become pretty important, is really, which application at the access layer do I want to remark to the right priority, and which ones do I want to mark back to priority 0? And you want to do that both at a layer 2 and a layer 3. Call admission control, which is today only done in Link itself, is something you want to at least think about a lot, because if you exceed the call capacity of the branch, all users will suffer, and you will defeat all the QoS work you've done. And then something else you can do is, if you're concerned about malicious users, you can actually add rate limiting policies on the access switch, so that if you're going to support voice, you could say voice is only 100 kilobits. If you're doing video, I'm going to maybe do 200 kilobits or 2 meg, depending on what that is. You can actually rate limit it, so if there's a malicious user, they will not exceed that bandwidth. Here's an example of mapping traffic classes to switch hardware queues. The majority of networking switches out here nowadays have 8 queues, but not all of them will have that. But this is a reason why you want to make sure you have more modern, up-to-date switches, and why having, say, a consumer-grade switch and enterprise-grade switch is a big difference. Most enterprise-grade switches will have QoS enabled. HP networking switches make sure that QoS is on by default, and we make it very easy to configure QoS, while some other competitors, QoS can be fraught with peril, because if you don't do, say, an auto QoS feature, touching anything is very brittle. So there is no right or wrong answer with QoS. Customers often have their own preferred mechanism, but what we've done is created some guidelines, some recommended best practices, which is a good starting point to look at. Voice should be the highest bandwidth from there's both layer 2 and layer 3. Layer 3 is the one I recommend using from a UC standpoint, which is what's inside the IP header field. And these are the values in here. So in here, you want to prioritize voice at the highest priority, which is low bandwidth but very latency sensitive. Real-time video, like Link video or Polycom video, you want to, AF41 is a good recommendation. It's got, high requirements like voice, but a high bandwidth requirements. And we recommend putting that below voice traffic. The signaling traffic, some people we find put signaling in the same queue as voice. But if you have enough priorities, it's good to put it as a separate priority. And then you can put some of your other applications down here. 0 is best effort. And there's something that's actually quite usable, is a scavenger class. And something that not a lot of people know is there are certain priorities you can actually demote and put below at a lower priority than best effort. And that might be things like peer-to-peer traffic. If you block traffic, users are very creative, and they'll figure out good ways to get around it. But if you demote it to a lower priority, if there's bandwidth available, they'll get the bandwidth. But if you need it for other applications, you'll starve them out. They think this network sucks, and they'll stop doing what they're doing. But if you block them completely, they'll figure out how to circumvent your IT controls. From a layer 2 perspective, it's always recommended to keep network control traffic at a higher priority, and this would just be a hardware queue. You don't actually see that across routed links. This way, your network can stay operational. Even if there's a denial of service attack, you can actually, your routing protocols will stay operational. Something that is really important is don't mix UDP traffic with TCP traffic. Okay, TCP traffic backs off nicely when there's packet loss. UDP won't back off. So it's recommended to not mix those. The only exception I will do with that is if signaling is UDP signaling, or if it's a low bandwidth low bandwidth TCP, you can mix low bandwidth TCP with UDP traffic. So the signaling here, even though it's TCP, it's low bandwidth, and you can mix it with either voice or video. But don't mix bursty data traffic with real-time traffic in the same queue. Otherwise, you'll defeat the value in here. So I kind of wanted to show a little example of how, with a soft phone and a PC plugging in a switch, how this kind of will work from a QoS policy and auto configuration standpoint. The majority of deployments we're involved with is the IP phone and PC are plugged in the same port. And the customers are doing this. They like doing this, one, because they don't, the cable for the legacy PBX was typically Cat3. The Cat3 cable can't run 100 megabit, can't run gigabit. It's not a high quality enough cable. So you may not even had a cable there to do it. So you don't want to run voice over Cat3 cable. So if you're replacing a legacy PBX desk phone, you have to use a Cat5 cable. So by using that same cable And using the same switch port, you can provide significant cost savings. A cable run gets expensive, on the order of maybe $100 or more per cable run. And by sharing the same port, you're only using half the amount of network infrastructure. So we're seeing that as a pretty common deployment. Most phones have an Ethernet port in the back, so when you plug the laptop in there, you simply pass the traffic through. But that means you need to make sure that you prioritize the voice and data traffic appropriately, even on this link, because this PC might be, a gigabit on the PC is pretty common, and when you're doing a PowerPoint download or you're doing email, that can impact the audio quality. When the phone plugs in, the phone will advertise LLDP MED, and most of the enterprise switches nowadays will support this. So this was a standard. I co-authored a standard and helped drive it, and I've worked with the majority of PBX vendors out there, IPPBX vendors. So virtually every enterprise phone vendor out there supports that. So if you've got an Avaya deployment, a Cisco deployment, you can run LLDP MED with that and Link phones. It'll get the right layer 2 QoS assigned, the right VLAN assigned. And you get, this way now, the PC traffic does not include the layer 2 priority. So what happens on this link here, the IP phone, you want to have tagged traffic on there. So that way you can identify what VLAN that's on. But the PC will not be using tags. PCs will not send tag traffic. So all the voice, video, and data traffic runs on the same data VLAN, whatever VLAN that is. And so what you need to do is you're going to want to do one of two things. You want to enable the QoS in the endpoint, and you can do that by enabling the QoS on the endpoint client and assigning the right policies, which is a little complex, but there's some good blogs out there on how to do that. And if you do that, you can then honor the DSCP markings in your network infrastructure. But since PC applications generally can't be trusted, a common mechanism is you start defining ACLs. But the thing is, Link by default uses ports 1024 through port 65535, which is pretty much the entire known range of applications ports out there. So if you're going to use these ACLs, you'll first want to trim down the port range that Link uses, and you'll want to use a separate range for voice, you'll want to use a separate range for video, and you'll want to use a separate range for desktop sharing. And that's important so that you can now assign a different ACL and different QoS policy for each one of those. And in many cases, remember that you're coming from another PBX deployment, so you may have Avaya running there. So you'll want to make sure that the port ranges you use don't overlap the default port ranges or the port ranges they've selected, so that you can prioritize that uniquely and differently from them. So what I want to highlight is some of the solutions we've done for Link and something that we're doing to really drive, I've been working closely with Microsoft on this, to simplify some of the QoS, because QoS is important, but it ought to be easier. Before that, I want to touch on a slide we have here that we've got, together with Microsoft, we've had a partnership for over 30 years now. They do a tremendous job on the applications. We've got partners with Polycom. We have a suite of endpoints. We've got server storage, networking, and a lot of services offering out there, and network management tools. So together, we can provide an end-to-end solution for both customers and partners through our portfolio. But the part I kind of want to highlight is we really have a networking vision to move away more from a physical to virtual infrastructure. We want to make it simpler. What we want to do is really orchestrate this and make it simpler, because today people are provisioning boxes typically still with a CLI on box-by-box basis, and that's hard to scale, especially as you need to put more dynamic policies out there for things like quality of service and security. And we believe we can fundamentally change the operating model and increase agility and improve your ROI. So what we've done is we've announced a proof of concept demo that we've done with the Link team, where we automate QoS and policy for campus enterprise deployment. And you may have heard software-defined networking. It's really one of the hottest terms out there. But today, it's really in the data center and carrier networks. And they're using it to really orchestrate the switches and take the control plane, the intelligence, out of the boxes and move that control plane more into a centralized box. So with OpenFlow, as an example of one of the SDN mechanisms we have, is we can use a controller to provision the switches, and this controller then can provide a lot of the business logic. But today, SDN is really in the data center, and what HP Networking is doing is really, we believe it makes more sense to have it be also in the campus and branch, and really driving an end-to-end SDN vision and architecture where you can do application service deployment from the data center to the endpoint client. So there's two key aspects of SDN. One is the control API to the actual switch infrastructure. So this is OpenFlow. So this allows you to take a lot of the business logic out of the switch and have more primitives in here. And then another important aspect is a northbound API. And what we have here is a UC&C SDN proof of concept application with an API to link. And what that allows us to do is do simplified policy deployment, dynamic prioritization, and enhance the user experience. And I'd like to run you a little demo video here of something we announced at the Open Network Summit in April. Is the audio on?
With this new UC&C SDN application, HP is now able to connect business applications, in this case Microsoft Lync, to the centralized intelligence of the SDN architecture. The UC&C SDN application automates network policy in a dynamic fashion, unlocking the full potential of unified communications and collaboration solutions through an enhanced user experience. Take, for example, two employees attempting to collaborate via Lync using application sharing. On the top left, we have the user James, and on the bottom left, we have the user Linda. James initiates a call to Linda and then starts sharing an application. As you can see, Linda's user experience is significantly delayed and not synchronized with what James is sharing. This is not a problem with Lync, but rather an issue with how the Lync traffic is handled across the network. This poor user experience is all too common with today's UC&C solutions. In fact, users are not only frustrated by this, they have come to expect this type of experience as the norm. The reality is that poor application performance is a drain on productivity and limits the power of unified communications and collaboration solutions. On the right-hand side of the screen, we have the HP UC&C application in a disabled state. When we enable the application, the user experience is instantly transformed. Now both users are seeing virtually the same information at the same time. The UC&C SDN application has taken call intelligence from the Lync server and used it to implement OpenFlow rules via the HP Virtual Application Network's SDN controller. These rules route and prioritize the application sharing traffic. The end result is a UC&C experience that is rarely seen across today's networks. Another unique benefit of the UC&C SDN application is that it provides unprecedented visibility to network administrators as to what is happening with application traffic on the network. Detailed call logs, including source and destination information, as well as call quality information, is passed to the UC&C SDN application and presented to the network administrator.
So what did we just see here in this demo? So this is something we're running down in our booth. So if you actually want to see this live, you can come down and we can show you this. But I kind of wanted to walk through this under a hood a little bit more and what we're doing here. And it's pretty exciting what this is going to open up in this solution. And what I'd like to highlight here is the switches down here. We've got 3 different switches. These are production switches. So this is a 5400 switch, 3800, and a 2900 switch. We've got over 40 different miles of switches out there and over 20 million ports deployed that already have OpenFlow out there. So this is not something that will require a complete rip and replace out there. On the order of possibly 20% of the customers already have some of these switches deployed in their campus and branches today. This SDN controller we have shown here is something that we've announced last year and will be shipping later this year. So the part that's the proof of concept is this part up here. So what I want to kind of walk through is what's going on. So when the user James makes a call to Linda, the traffic is encrypted. It's using SIP TLS. So using DPI or deep packet inspection really is not very useful to figure out what's going on the traffic. It could be any kind of traffic. But the Lync server is involved with that call setup. So once the Lync server knows what's going on, via RESTful API, communicates to our UC&C SDN proof of concept application, and then on a per call basis uses OpenFlow to provision the QoS policies and the forwarding policies on all the switches for the duration of that call, but only for that call. So then when the call is set up, the QoS policies are properly set on those switches only for that specific port number, so only that one user, and any other application will get the default service. And then when the call is ended, we tear it down. So it's on a per-call dynamic QoS policy. It doesn't require any provisioning from the network end administrator. It's really as easy as a push of a button. And it's going to enable a lot more things going forward by doing this kind of mechanism. Instead, today, people leave fairly wide open port ranges on all your endpoints, and if users know what port ranges you're doing, they can hijack that traffic. But that's how things are done today. So we believe this will really dramatically change how people provision networking infrastructure through much more application integration with applications out there. I also want to touch on some of our WAN routers. We have a pretty capable portfolio of multi-services WAN routers, and this is something maybe a lot of people don't know. But we've got a variety of different models. I'm going to highlight only these models here. We've got over maybe 20 different specific models, but we've got an MSR 20, 30, and 50 series, and these are well suited as a all-in-one kind of branch-in-a-box solution. They integrate routing, switching, wireless, even 3G, voice and security, and you've got a wide assortment of PSTN interfaces. And the question is, why is that important? As you're doing a link deployment, you're probably aware of the SBA role, the Survival Branch Appliance role. This can support both a media gateway. So if you want to have an enhanced media gateway, this is something we should be qualified, hopefully the end of this week, if not the next week, as an enhanced media gateway. But if you want to then also have it be a Survival Branch Appliance, we have a module in here, and we got 3 different flavors of these modules. So we got a small, we got a medium, and we got a large. So depending on your branch sites, we can provide you a Survival Branch solution. And in many cases, when you're doing a link deployment, you're not necessarily going to want to do a WAN upgrade. So this can be deployed as an appliance today. But it really is also a full-fledged WAN router. And when you're ready to do a WAN upgrade, or for the sites that need to do a WAN upgrade, you can discard your WAN router and use this as a WAN router. So it either can be used as a media gateway, it can be, or as an enhanced link-optimized media gateway, it can be used as a Survival Branch Appliance, or it can be used as a full all-in-one WAN router, including Ethernet switching and PoE. And it'll be Link OIP certified. They're going through the certification, and it'll be listed on the website once the certification's complete. Yes?
So I imagine most of the folks that you're probably maybe the BD1000.
Yes.
So how would this stack up to that price?
From capabilities-wise or from cost competitiveness? Scalability-wise, much more scalable platform because it's got and capability platform. This is a full WAN router. So if you want to do things like MPLS, if you want to do things like either small or large capacity of WAN capacity, this is a very capable box. This will compete against the Cisco ISR platform. Cost-wise, very competitive against the Cisco ISR. Performance-wise, we typically are higher performance than the Cisco product. So it's a more functional capability. It tends to be more scalable. With the MediaNet, you have to go to different platform families, and some are much more fixed configuration. This is a highly modular box with a lot of different interfaces. Especially if you want to still use analog ports. We find in a lot of customer deployments, fax isn't necessarily going away. And so you might not have a lot of sites, but you might have some sites that need maybe 50 fax machines or even 100 fax machines. So it's hard to find solutions out there that provide large-scale analog connectivity. And we've got 24-port analog carts, for example, that can go in there as well. So we can scale down pretty small and pretty large, and from a price standpoint, very competitive. If you're interested, stop by the booth, and we can give you more information on that. We also have a full suite of, we have link-optimized phones. We've got both a knowledge worker and a common worker phone, high reliably, seamlessly integrated. So they're running the Link Edition firmware. Assume most of you are familiar with that. We have some of these down in our booth as well. Something that we've done on our phone is the common area phone has a speakerphone in it, which most of the other common area phones don't have that. We also have gigabit, so both of those phones are gigabit. Another thing we've done is the hook switch is usually a part that breaks on phones, so we have an electronic hook switch for higher reliability. So we've done a number of features on here that we feel make it a higher reliability and more functional phone than some of the competition. We also have a HP services for customers. This is more targeted for larger enterprises. For going through the channel, that's where the channel solutions are more targeted. But for customers that are going more direct, or if any of you are Microsoft folks going into accounts, going with HP Technology Services jointly together is maybe a good way, especially if you've got customers that may need a network service assessment. We can often talk to these and do a workshop with them, and that can help for customers who might not think they need a network assessment. We typically do a workshop, can do that up front, and talk about some of our strategies, the technologies, and what we're trying to deploy. So we've seen that be successful by going in together. When we go in together with Microsoft to an account, our win rate goes up significantly. The Microsoft guys know Lync really well. They know the application really well. We know data centers. We know networking really well. And we've done a lot of voice deployments and voice assessments out there. Any questions on that? So I want to touch on our internal Lync migration. So we're one of the largest Lync deployments out there. Today, we have over 300,000 employees and contingent workers using Lync internally for IM, presence, PC-to-PC calling. But we haven't forced them to give up their conference calling service. But we have over 120,000 employees using that every month, and that adoption rate keeps going up. Once they start using it, they start realizing how much easier that is to click to conference than dialing the conference pins. And the audio quality experience tends to be significantly better over this service. We're in the process of piloting Lync Enterprise Voice. We've got on the order about 20,000 users deployed across different branch sites running Enterprise Voice. And we're going to be targeting to have about 40,000 in the next couple months. And then we're going to have a pretty rapid pace to try to upgrade and migrate the rest of the organization. But it takes time to upgrade 300,000 users. Doing the IM and presence is pretty easy. Doing the PC-to-PC calling is still pretty easy. But doing the enterprise replacement can be challenging. Even things like dial plans. You have to do dial plan normalizations. And typically, you tend to have a PBX there as well. So interworking with existing PBX. There's some things you really have to think through as those deployments are out there. And what we've done is all the sites that are running Enterprise Voice right now, we still left the PBX on their desk. So a lot of users, what we've seen is they may not realize that the desk phone's going away until we're done, until the PBX gets shut off. And all of a sudden, some users go, hey, what happened? I didn't think you were going to take that away. Make sure you set that expectation appropriately beforehand. And just because you communicate it doesn't mean they read that email. So, we've seen strong adoption, and that adoption keeps growing. The users that use it tend to be extremely satisfied. And I even talked to users who early on just even didn't get the Lync aspect. They go, I don't know, why do we even need Lync? I've got Skype or some of these other tools out there. But once they start using it and playing with the seamless integration of it, the ease of use, and especially the enterprise voice capability is very exciting. And looking forward to when we start doing the mobility deployment. We currently have that disabled because IT's got their hands full doing the enterprise voice migration. And just to highlight this is all running over HP networking infrastructure. Both our data centers, our WAN, and our campuses are all running HP network infrastructure, so supporting one of the largest deployments out there. I also wanted to highlight two customer success stories, and one of them was Black & Veatch, and this is where our technology services did a Microsoft Lync deployment for a customer. Initially, it was 2,700 users, mostly in the headquarters, and cost savings was a really important aspect for them. So we really provided a compelling ROI model. The initial deployment was so successful, they increased the rollout
to 8,000 users. And not only did the deployment pay for itself in 18 months, but the part that they were really excited about is it provided an additional $650,000 back to the business. Okay? So that's a big part. And something what you need to think about is while you're doing a rollout, be careful returning that money too early. Because if you get some cost savings and return it early in the project, you may not be able to fund the rest of your project. So make sure you have a right multi-year phase of what you're trying to roll out and use that savings to fund some of your other UC initiatives before returning all the cost savings back to the business. So I'd like to highlight another solution. This was done through channel partners. And this was a HP networking deployment. This was initially going to be a Cisco, all Cisco network, Cisco Call Manager deployment. And we deployed it with HP networking, Microsoft Link, HP IP phones, the WAN routers, the MSR routers that I highlighted across 47 branch sites. The customer, we did a proof of concept together with the Link team. The customer was very impressed with our capabilities, our functionality. We showed them a POC, a production POC. The price was better than Cisco. And the clincher was really a successful solution workshop where we highlighted the solution in the customer environment, hands-on, where they got to play with it. So kind of as a summary, so the key takeaways is don't forget the organizational political aspects. Virtually every customer I've talked about that's larger, if it's in a small shop, one guy does it all. But most larger organizations, the organizational is a big aspect. Don't underestimate that. The Microsoft team, knows the application guys very, very well and very favorable to them. But that doesn't mean the networking team is on board with that same deployment. In many organizations I've seen that the application team understands, the functionality, the benefit, the user adoption. The networking team, on the other hand, it's a threat to them. They're losing a lot of control over both budget and functionality with that shift in there. And make sure that you include or think about that from that rollout in there. The other aspect that it requires more networking and voice experience in addition to core Microsoft technology skills. So sometimes we've seen that in an organization where they're not prepared, if they have the voice expertise but not the application expertise, sometimes that can be a stumbling block as well in deployment. So make sure you get them the right training if they're not Microsoft knowledgeable on the right tools. It's a little bit different and a little bit more complex because of the moving parts, but once they deployed and have been trained, you'll have success with it. So organization political is important. The user experience, don't underestimate that. Keep monitoring the user metrics and support issues closely, even if they don't complain. The usage will steadily grow due to ease of use. The ease of how easy it is to use Link in the modalities of the communication, people will embrace that. And lastly, don't underestimate the importance of a network assessment. The quality of the Link experience is only as good as the quality of the network. And you want to have a successful customer deployment. Don't be like that story I told you at the beginning where the customer had a successful pilot, started the rollout, and then the networking guy came back and said, hey, boss, I told you so. Link wasn't ready for prime time because he ensured that the Cisco Call Manager had QoS, but he made sure that the networking infrastructure didn't provide QoS for Link. Also, please stop by our booth. We can give you a hands-on demo of what we show around software-defined networking and how that's going to dramatically change application deployment. Thank you. And if anybody's got any questions?
So on your demo there, the software-defined networking, if QoS was enabled properly from the get-go, would the original image on the left have been like that?
The image on the left was with the QoS disabled.
Yeah, but why do you need the software-defined networking? Why not just use QoS properly from the get-go?
Correct. If you can do the QoS provisioning, it'll give you the same experience as that. But what we find is it takes a lot of expertise, and it's a little bit complex, especially as you're doing it for soft phones and mobile devices. So absolutely, doing QoS today via the CLIs or network management tools works, but we believe that there's even a better way of doing that through software-defined networking. So agreed. In all the deployments we've done so far, we give them the same experience as what you saw once it's enabled, but it took a lot of work to do that. So we believe that the software-defined will make it simpler and more scalable for deployments because setting those policies does take time. And human error is the piece that we find causes the biggest problems. I don't know if you yourself done QoS configurations of ACLs. You're entering a lot of port numbers, like UDP port numbers, and it's very easy to transpose 2 digits. So instead of 48, it's 84 or something. No, that wouldn't be right. But instead of 4,300, you go 3,400, and it's almost impossible to catch. And it takes a lot of troubleshooting to fix it. Because I find connectivity issues are easy to diagnose, right? Connectivity issues, you either ping or you pick up the phone, even dial plan issues, yep, okay, it's working. QoS, on the other hand, appears to be working, and it only is an intermittent problem when capacity is reached. So it's a little bit harder issue to validate up front. It can be very difficult to validate up front, and it's much harder to troubleshoot because it's only an intermittent problem. Any other questions? Thank you.